something really quick. Although in AB I don't need to cover, BC I don't need to cover this, but I would rather cover it just at least that you guys know the idea behind it, and that's a very important for you guys to know. And AP exam does test stuff like this. Um, we are gonna talk about rectangles um, later. We're gonna talk about when we go into trapezoidal rule and left and right end. We're gonna talk about all together. So I'm gonna skip that part. Usually you're supposed to talk this first. So basically, integral or antiderivative.
Wait, are we doing Riemann sums?
Yeah, well, we're gonna do that later. We're gonna do just straight go into integral first. But you're supposed to do Riemann sum before you do that. But I would rather talk about it at the end. So we're gonna talk about everything together. But we can start by the antiderivatives. Antiderivatives is also known as integral. Okay, so today we're going to talk about what's the difference between definite integral and indefinite integral, and talk about those things. So let's talk about, I'll just give you a brief description of what happened last year. Then we're going to go back and talk about those questions. Hopefully that's okay. So what I'm going to do is I'm going to search Riemann sum. I don't know if I spelled it right. I don't spell it right. Okay, Riemann sum, Desmos. I don't like this one. I don't like this one. I like this one. So you guys already know derivative. Derivative is finding slope of a functions. Okay, finding slope of a function. If an integral, antiderivative, a definite integral at least, there is a boundary. There is a boundary from A to B. And now we're gonna come back and talk about this later. But this is a very good illustration. So what happened is, I don't know if you remember, in the back in the days, they say, can you find the area of this? And basically, you're just gonna go in counting how many squares they are, and that's your square miles per hour. Or you want to calculate how big the island is, and you do a approximation. Do you guys remember that? I don't know which grade is that. Which grade is that? You're gonna say like, okay, this is 1, 2, 3, 4, 5, 6, and all those, like, this is a half, this is a half, something like that, and just kind of count it up. Have you done that before? Which grade? Third? I think that's important stuff, to find out how big the area is and just a undefined shapes, right? So what happened is integral is different. The integral is going to be pretty much count up the rectangle. So at first, we want to find out the integral means the, wait a second, that's not right. It means the area under the curve. So there are a few ways to approximate something. So first of all, we're gonna change that. Sorry. We're gonna change that to maybe 4 rectangle. So first, we want to find the area of curve. We can use the 4 rectangles. Okay. And that rectangle is based on, this case is based on right endpoints. Do you see why it's based on right endpoints? Yeah, but it's toward the end. You're not based on the right. You're not based on the left endpoint. And this case is right endpoints. And the idea is, you just figure out how many rectangle they are. So if I do this, in this case, I will figure out that's 1, 2, 3, 4, 5, 6, 7, 8. Probably like something around 8 or 7-ish. And you can figure out, that's probably approximation. How big is it? Now, what the definite integral was use Riemann sum, which is using definition of integral, which is we're not going to talk about because we don't have time to do it. But if those are you guys interested, we can talk about it when we get more, because we got to talk about other things. So basically, you just turn this rectangles, right? Turn this rectangle to maybe 1,000, right? And you're gonna say, okay, well, what you're gonna do is, a definite integral is turned to infinite, actually, to have infinite amount of partitions. infinite amount of partition, then you can say, if I change to 30, it becomes much more precise than before. So if you see like this, and if I see at 5, there's some overlap, there's some underlaps, so there was like over a little bit of over approximation in this case because the last break kind of give you more information than the other one. So as I'm increasing, right, and to 1,000, but a definite integral is actually to infinite. Now you basically don't find, you still find a little bit, but you have to zoom in so much to see that small discrepancy. And that small discrepancy is gonna be, eventually is gonna flat out completely if I change to a min rectangles, 10 bin rectangles. Now, what happened at the antiderivative of definite integral is changing to the n partition to infinite amount of partitions. So infinite amount of partition, there is no small rectangle difference anymore. You'll pretty much sum up everything. Now, the proof of that, we can expand. We can do that. I can do that on a separate video just for people who care. I don't want to do that to work on anything, but later on we can talk about those. So I will do that on a separate video. But you don't have to watch them because that's probably not a good testing materials. Question about this. So you can play with it, and there are also there are different way of doing something. So let me go back to here. There is a different way of doing something that say, I don't know what the hell is going on here. Okay, anyway, let me do it here then. Riemann sum. Okay, let me save to this file. I'll save it here, and I should be able to see it from here. Oh, do I see it? Yep. Okay, so what happened is let's reduce that. And there's definitely a different way to do a approximation. There are a few different ways, so let me introduce you. There is this is right endpoint approximation. Now let's look at the left end approximation. It's gonna look like this. This is left end. Let me unhighlight the right end. So you can see this is called under approximation because you see this is which area is bigger. Let's compare both as side by side. The lighter green color is gonna be overrated. And the things about the idea is to look at it, if a function is increasing, your right endpoint approximation is going to be bigger than left end approximation. Does that make sense? Because the function is increasing, you base on the highest value to draw a rectangle. And if you base on higher value to draw a rectangle, you're going to have a over approximation, and as opposed to left end approximations. And those are the things that you had to justify on AP exam. Those of you guys that did AP exam last year, you had to justify this. Is this over approximation or under approximation? It really depends on if the function is going up or going down. Okay, if it's going down, then right end is going to be under approximation because you base on the right end points. Okay, so there are other ways to do it. So there's left end, there's right end, there is a middle, right? You don't base on the right end or left end, you're based on between the two spaces and use those two spaces to judge the high value. And so this one's actually is a better approximation compared to the other one because you see there was overlap on the last square and there was also an under, so they are pretty much evened out. So far as the midpoint or right point or left end point, I do think midpoint is better approximation than either left or right. Now, what's even better is using trapezoids, which is we're going to talk about the trapezoid rule, which is like this. You just connect the 2 points and building a new trapezoid. And if you're building a new trapezoid, now The trapezoid is different to see a concavity. Okay, so I'm gonna mention this again later. Is the way to justify are they over approximate or under approximate is depends on what? Do you guys remember? No. Concavity. Good job. Eva and the Gabby is really depend on concavity. You see on the right hand side, on the right portion of this graph is concave up, right? It's concave up. The way you draw trapezoid is gonna have an overlap. Do you see that? Now it's concave down. The way you draw a trapezoid is gonna be an under approximation. Do you see that? So in this case, it happened two times. Two things. It depends on concavity. So concavity is going to tell you, like, how do you justify? Are they overlap or underlap? You can tell by this graph. And there's two illustrations here, concave up and concave down. They're going to give you, are they over approximation or under approximation? Now, if you take this in college, we don't actually talk about this. We don't talk about when's overlap, when's underlap. If you take in that in University of Pittsburgh, I don't think they talk about this. Yeah, they don't. It's because it's pretty useless. But AP exam, because they want to make things a little bit easier for students, they won't. But actually end up to be harder because actually you had to think about those small things. So it's actually not good, I think. So I don't prefer to talk about it, but I have to talk about it for AP exam goes. So this is that. Okay, later on we're going to talk about how to calculate. Is that okay? And we're going to talk about it in one day. We're not going to take it. We're not going to spend 20 days to do it. But I just cannot do it in a short day. Antiderivative is area under the curve. So what I mean by that is, and they usually have it up the boundaries 1 and 3, and let's just say 4 dx, right? So what is it? What is without anything, without knowing the rule of definite integral? How would I find the area of this without using integral? Without using integral, like let's just say I don't know how to take integral. How would I do it? Yes.
You just imagine the graph from y equals 4.
Uh-huh.
And so that's just going to be a horizontal line. So, and then the parameters are going to be 3 and 1. So that's a distance of 2.
Yeah, good.
And then so 2 times 4, 8.
So this is called geometric way to find the integral. Why is geometric way is find is very, very important because we're going to talk about it in a second. It's actually super important for me because students, they usually have a hard time doing stuff like this. And that's very, very important. Now, can you take a normal integral to do this? Normal integral is going to look like this, which is a 4 dx between 1 to 3. What you're going to do is going to be 4x. It's actually longer work between 1 and 3. And basically use the fundamental theorem of calculus is going to be 4 times 3 minus 4 times 1. So basically the upper bound subtract the lower bound, that's equal to 8. So work is actually quite more. If you understand geometrically, that's like, yeah, that's just to understand that it's much, much more efficient. But most of the time we're going to deal with algebraic way to approach it. Geometric way is very, very important. Why is geometric way important? Can I do this without using integrals? Can you do it without it? Without taking integral? I mean, I know you guys can take an integral, which is x squared over 2 plus 2x between 3 to 0. And you can plug in and you subtract it, upper bound and lower bound. Yeah, you can get a value. But can you do it without the thing?
It's simple enough, probably.
Yeah, how do you do it, Alex?
So you do, the normal graph you did before.
Mm-hmm.
You place x-intercept is 2.
Mm-hmm.
Then you go up 1 until you reach 3. And you can make a triangle. You have a box at the bottom from 0 you were to this, then you have that 6, right? And then you have a triangle, 1/2 base on side. It's 3 high, so like if you have just 9, the whole thing.
Yeah, but it's 9 divided by 2 because it's triangle, right?
Well, the triangle is only like 3.
It's a 4.5 actually. Okay, so it'll be 4.5 plus 6, it'll be 10.5. Now, the way to think about it is I actually don't break it up to pieces, just do it a trapezoid. You practice 2 things. One is this is a base, this is one side of base, and this is another side of base, right? So we are reviewing about a trapezoid rule. Okay, so basically the trapezoid rule is going to be one base plus the other base divided by 2 times the bottom, which is 3. So it'll be 7 over 2 times 3. That's equal to 21 over 2. He break up to a rectangle and a square, but that's good. But rectangle, a triangle, but that's good. But that's not very efficient for us. You had to do 2 calculations once. You could have done it with 1. And that's also review a trapezoid rule. Now, why is this trapezoid rule? Is because if this is a parallel line, because they are straight line, right? If it's straight line, they both have parallel. If it's a parallel, that means the bottom part is the height. Each width of a trapezoid, the bottom part is the height, not 2 or 5. 2 and 5 is actually 2 bases. Okay, 2 plus 5 divided by 2 is average of 2 base multiply the bottom. So that is 1 trapezoid. So we are reviewing about trapezoid rule. Are we okay? Okay. Now the next one is a little bit more challenging. I don't think anybody can do this. I'm going to challenge you guys to do it. And this will be on the test. Okay. I do think there is probably maybe 2 individuals can do it in this classroom. I don't know which 2. I think I have an idea which 2. And guess what? There is no way to do it algebraically. No way. There's a way. You need to know Calc 2, but since I haven't teach Calc 2 yet, so you won't know how to do it. There's probably 10 different ways to do the same question. But the easiest way You got it?
I think so.
Okay, good. I have 1 person already got it. I'm looking for the second person to get it. There's no way to do it algebraically on this question. No freaking way. Only can be done with geometric. That's why I talk about geometric. AP exam happen to really emphasize on geometric, and I think this one's a good question to talk about geometric. Nisha got it? Good. So like I said, 2 people. Oh, Bobby got it.
I think that's one.
Oh, that's smart. Okay. So so what did you get, Bobby? So you are the 3rd one. Very impressive.
Is this the thing
But you kind of cheated though.
You didn't say I couldn't.
Yeah, I never did. I was hoping you would cheat. Or just you kind of follow on my sim track because I didn't teach you, so then you probably have to know. So how do I know that's a semicircle? First of all, you have to know a circle is x squared plus y squared is equal to r squared. That is a circle equation. Do you guys remember that? So then if I solve for y, so that's equal to r squared minus x squared. Does that make sense? And y is equal to square root of r squared minus x squared plus minus. Now, what do you mean by plus? This is the plus. So we're just reviewing a little bit about this. So this is the top part, And if you have a y equal to negative square root r squared minus x squared, that is the bottom part. Does that make sense? So that makes a complete circle. That's why you have plus minus. So really depend, you want the top part or the bottom part. So, and this one's on your test because you have to know your radius is 2. And then they restricted from -2 to 2, so that makes this, I just want to find the area from here to here. And good job, Bobby, for cheating, which is good in this case, because I didn't allow you not cheat, so technically it's not cheating. Because you look it up the graph. He says, well, geometrically, I'll just look at a graph, I'll figure out, which is that's what you're supposed to do. But now you know algebraically how the things work. So you know this is a circle, so you know this is the area of this. So radius of 2, so it's going to be semicircle. So semicircle is going to be 2 times pi over 2. So that is equal to 2 pi. Because pi r squared divided by 2. So it's going to be 2 pi. Now, can I ask you a different radius? Of course. Can I ask you that integration from -7 to 7 square root 49 minus x squared? Yes. Can I ask you between 0 to 7? Yes. That'll be a quarter circle instead of full half circle. Huh? No, what be jerk move will be something like this. This will be a jerk move. This will be a jerk move. This will be an ass move. Oh, negative. Yeah. That would be a jerk move. That would be a harder question because you're trying to calculate the area between this region.
Wait, how'd you calculate the area for the semicircle again?
The semicircle is the area of whole circle is pi r squared, right?
Yeah.
So full is equal to pi r squared. So semicircle is pi r squared over 2. So therefore radius times pi over 2. So it'll be 2 pi. So this is 2 pi. Pi r squared times half. And r is 2 in this case. Does that make sense? Yes. No, substitution doesn't work because there is no 2x outside. In order, or they will have first degree. So in order for you to do substitution, you have to have some type of x outside. You have to some type of u equal to 4 minus x squared. Du has to be a first degree. So you don't have that. There is u substitution does not work. Now, trig substitution might work. And we haven't learned that yet. And you haven't learned that yet. So trig substitution might work. But we're going to come back and talk about if it's trig substitution in this particular case. Good? Before I move on? Okay, great. So let's talk about some basic thing, which is he just mentioned, which is good. Thank you. So two special definite integral between a definite integral between a and a of f of x dx, because from a to a there is no things on the bottom, there is no area changing. So it's going to be integration from a to a of f of x dx. It has to be equal to 0 because there's no area underneath. Very, very intuitive. They're not complex. Are we okay so far? Now, the next thing is, what if I have area between a and b of f of x dx, right? Can I switch the boundaries, right? Can I switch between a and b? Yes, you can. If I switch that, okay, so remember, this is a switch. So b to a of f of x dx, that basically just means the negative of that. Because the way you calculate the area is calculated differently, so you're going to have a minus sign in front of it.
Still the same numbers.
It's still the same number, but it's going to be a negative sign with it. Are we okay here? The negative sign could be on the first one, so you can erase this negative sign, and you can say negative sign this. You can do that too. So if you switch the boundary, you put a negative sign in front. And AP exam love this, which is I don't know. I mean, it's important, but it's not like not like important. Question about that part. And you guys do have a homework about this?
Oh, Mr. Gay.
Yeah.
About what though? Like, we didn't do any actual Riemann sums.
Yeah, we can give it work.